Good evening, everyone. Welcome to Unacademy. Welcome to Kreatryx channel. So let's start the session on AC analysis from the Brahmastra batch network analysis crash course. So this is a crash course on network analysis. We are discussing this course from the past 2 weeks, and this is the last topic in this particular course. And tomorrow this is going to complete. So in this particular session, uh, I will be discussing the basics of the AC analysis. So last time we discussed the transient. I skipped the AC transients intentionally because it is not very important. Crash course may it's fine if you can skip that also. Regular course may I have already covered. If you don't know the basics of it, you can go through it, transient preconditions and all. So here we will be discussing the AC analysis. That is the basics of the AC, how to represent the signal in the form of phasor. After that, we discussed the sinusoidal steady state analysis, phasor diagrams, most probably resonance also today I want to cover. The remaining topics we will be discussing tomorrow class. So let's start the session. So आप लोगों को पता है अभी अनअकैडमी में बहुत अच्छी से ऑफर चल रहा है दैट इज 23% ऑफ ऑन अनअकैडमी सब्सक्रिप्शन दिस इज फर्स्ट ऑफ इट्स काइंड गाइस अभी तक you never got this kind of offer. This is the first time you are getting 23% off on an academy subscription. आप लोग कितना सेव कर सकते हैं आपका सब्सक्रिप्शन में. All you need to do is use the code Shankar10. That's enough. Okay, चलो let's move further. So these are our toppers from ESC 2022, and for electrical engineering and EC, these are our toppers, guys. Okay, from electrical and EC. So this is the batch presently going on with what we call GATE and ESC 2024 aspirants. That is UDAN batch. This is also for the IRMS aspirants, those who are aiming for that, and 25 aspirants के लिए. Network analysis is started by Umesh sir daily at 7 p.m. in the evening. So we will discuss a little more about the subscription and all a little later. So let's start. So in this course, I want to make you, I save your time because it is a crash course. So मैंने ऐसा plan किया, theory को already मैं तो लिख के slides लाया such that it will save your time so that we can concentrate on doing more and more number of problems in the available time. So that is my intention. So let's start that. चलो. Let's start. So let's see the topics we are having in the AC analysis. If you take AC analysis, we have many number of topics. इसमें the first one we discussed phasor representation. Then sinusoidal steady state analysis. Phasor diagrams. Then resonance. Then average and RMS values. And also power calculations. We have some topics like locus diagram, and filters. So this is what you have in the EC syllabus and also electrical syllabus for the GATE. So exclusively GATE electrical, you have magnetically coupled circuit, and also three-phase circuits. So this is your syllabus. So today I'm planning to cover this, and this. Let us see how we can be able to do this. Okay, so let's start. So, so let me give you a signal, for example. Okay, V of t equal to Vm cos omega t. So this is called the maximum value. Okay, this will tell you the frequency, and if you have some initial phase compared to its what we call regular signal, then it is called this one. If you have some initial phase compared to the standard signal, then we have the phase shift. Okay, that basics I hope you people know. I'm not going to that particular level of the basics which I do in the regular class. Now here, for example, we have 10 cos omega. Okay, what is the maximum value here? 10. RMS value 10 by root 2. What is RMS is root mean square value. It is maximum value by root 2. Suppose if your V of t equal to 10 by root 2 cos omega t. Here what is the maximum value? Here also the coefficient always represents the maximum value, and the RMS is the coefficient upon root 2, that might be 10 by 2. Similarly, suppose you have V of t equal to different examples and 10 root 2 cos omega t. Here also this coefficient always represents the maximum value, and the RMS value will be maximum by root 2. So कोफिशिएंट पे ऑलरेडी रूट टू है, बाई रूट टू है, नहीं है, कुछ भी नहीं हो सकते. कोफिशिएंट पे जो होता है ना, इसको हम हमेशा क्या कैसे लेना चाहिए? We should take it as the maximum value. Okay, so let's move further. Now, so in the time domain, the coefficient is always the maximum value. But in the phasor domain, coefficient can be either maximum or RMS, depends on the uh, representation. कुछ नहीं specify किया तो phasor domain में we take it as a what we call RMS. What is this phasor domain? I will explain it now with the help of one example. See here. Suppose you have a signal. We can take it as a representation one. Say you have a signal V of t equal to example Vm cos omega t plus phi. Okay, then listen carefully. You can write this as e power jx equal to cos x plus j sin x. So this can be written as the real part of, or firstly you write this as Vm can be written as uh, multiply with root 2, divide with root 2. This value will remain same. So this will be root 2 into VRMS cos omega t plus phi. Okay. Now root 2 into the real part of VRMS e power j omega t plus phi. Okay. Right. So here you can see, you can write this as root 2 into. Today in this session, I don't have access to read your comments, so I'll be explaining. Okay, if you have any doubts, next class you can ask. VRMS e power j omega t into e power j, because e power j into a plus b can be written as a into jb. So now this can be written as root 2 into the real part of phasor v into e power j omega t. What is V, sir? Phasor V? Phasor V is equal to VRMS e power j. You can also write it as VRMS angle phi, or you can also write it as VRMS cos phi plus j sin phi, right? So exponential, polar or rectangular form. When you are multiplying the cosine or sinusoidal signals or dividing them, we may use the exponential and polar form, which makes your analysis easy. If you are doing the addition and subtraction, what we call rectangular form will be more helpful. So this is the RMS value will be represented for the ease of convenience. You may have the doubt, sir, why should I divide with root 2 and multiply root 2? Is it okay if I don't do that? It's absolutely fine. You can directly take the maximum value and represent the phasor also, nothing wrong. Sorry, nothing wrong. But why we do this is in power calculations, etc. RMS makes more sense. Because of that only we are using it. Otherwise, there is no need compulsory. You should take the RMS. So you see, the same thing I can do by directly taking the maximum value also. Suppose 3 angle 45 degrees is there. I assume 3 as the maximum only and write the mathematical equation. Similarly here, if you have 3 angle 45 degrees. What is the meaning of 3 angle 45 degrees? It is originally, this is RMS value. Convert into maximum cos omega t plus 45 degrees. This is the time domain. So time domain में हमेशा it should be maximum. In phasor domain, it can be RMS value or you can represent maximum also. It depends on your choice. So if examiner specified nothing, we always take in the phasor domain the coefficient as a RMS value for the safety. Okay. You can represent generally by default we assume as a cos and represent. Sometimes you can represent sine also because cos can be converted into sine, sine can be converted into cos by addition or subtraction of 90 degrees. Okay. So you can convert any signal into cos and represent one way. नहीं है तो directly sin भी represent कर सकते हैं, but assuming it as a imaginary format. सर confusion हो सकते हैं ना? नहीं. आपको पता है आप कौन सा representation follow कर रहे हैं. When you write it in the reverse, you should follow the same representation. Nothing specified. Assume phasor domain coefficient is RMS and cosine sinusoidal signal. Okay. When you have the question in both time domains and you are converting and reconverting, it is your own choice. Whichever method you apply, you reconvert in the same way. But one rule you should compulsory remember: in the time domain, coefficient compulsory must be assumed as maximum value only. Phasor domain, mein coefficient can be anything. So right. So let's take this question into consideration. You have applied voltage applied to a circuit is 100 root 2 cos 200 pi t, and the circuit draws a current of 10 root 2 sin 100 pi t plus 45 degrees. Okay, taking voltage as the reference, then what is the current value? Firstly, what is the voltage value? 100 root 2 cos 200 pi t. Current is 2 10 root 2 sin 100, we are 100 pi t minus 45 degrees, pi by 4 na, so plus 45 degrees. Okay. Now what is the current phasor I? How to find it? You can give a try. So this is 10 root 2 angle minus pi by 4, 10 angle minus pi by 4, 10 angle plus pi by 4, 10 root 2 and 10 angle plus pi by 4. So if you want to give a try, you can try. It's not a great deal. So this will be 10 root 2 cos 100 pi t minus 45 degrees now, because if you subtract 90, because this is your reference is in cos, you should take cos only, don't directly take plus 45 degrees. Okay. Now this can be written as 10 root 2 angle 45 degrees. Okay. Or if you take the maximum value into consideration, you can also represent this as 10 angle minus 45 degrees. You take RMS into consideration. ठीक है, चलो. चलो. So both are given in the. To be frank, both are correct. But to be more precise, you should go for the option B. A and B both are correct, but A and B both are correct, but we should take, if both are available, go for the preference of RMS only in the phasor representation. Right. So that is the example I want to give you. So in the time domain and phasor domain, what is the advantage is it makes your mathematical part more easy. It will make your analysis more easy. So if you take the time domain, phasor domain, okay, resistor will be resistor only. Inductor will be replaced with j omega L. Why j omega L, sir? Because d by dt of e power j omega t is equal to j omega into e power j omega. Then differentiation is getting converted into multiplication. So what is L di by dt? It is j omega into L into I. Okay. So see here, I mean d by dt is replaced with j omega. That is the reason we replace inductor with j omega L. This is applicable when your input is in the form of sine or cos or multiple, what we call addition or whatever the sum of the different both also. So DC or other inputs may don't apply this inductor equal to j omega. Capacitor we replace same way 1 by j omega c. वोल्टेज सोर्स है तो हम रिप्लेस करेगा V से, करंट सोर्स है तो I से रिप्लेस करेगा and V equal to IZ or Z equal to V by I. Here also, like Laplace, we solve only by what we call multiplication and division, no need of differentiation and integration. Just a minute. One minute. Okay. So these are the basics of the phasor. Now let's move for the next topic called phasor diagrams. Okay. So here actually I generally draw everything and I will explain, but still बहुत time लगेगा, उतना time हमारे पास तो नहीं है. So at the last moment of the exam, so directly I am taking the I have already taken written everything and now I am explaining with the help of that. So if you take a series RL circuit, so this is the RL circuit का phasor diagram. So RL series circuit में current हमेशा constant रहेगा. So we should take current as the reference. So V equal to IR IJXL. That is IXL angle 90 degrees. So what is your V equal to? VR plus VL. So now listen carefully. So current is the same. Voltage in the resistor will be V equal to IR. Fine. Voltage current in the resistor. Voltage in the resistor are in the same direction, same phase. What about inductor voltage? IXL angle 90 degrees. It is like this. If you add these two vectors vectorially, this is the result. What is V? Root of VR square plus VL square. Here, this will give you the resultant V, sum of these two. The angle between V and I is that is the source voltage and source current angle will tell you the impedance or admittance angle of the network. Okay, or so what is phi here is tan inverse of opposite by adjacent. You can also write x omega L by R because VL equal to IXL, VR equal to IR. So here power factor is given by cos phi, y cos phi, etc. We discussed in the power calculations. That is given by VR by V. That is I into R by I into Z, which is R by Z. Okay. Here you observe voltage is going ahead of current. Current lagging behind the voltage. इसलिए इसको बोलते हैं lagging power factor. So what is the impedance is voltage angle by current angle. Current angle is generally here less compared to voltage. So the difference between them will be positive when it is lagging. If it is current is going more than voltage, V by I angle is negative, then it is called leading power factor that you get for RC circuit like this. I will show you. So you can see RC circuit also same analysis, but VC equal to minus IJXC or IXC angle minus 90 degrees. So ये उल्टा आ रहा है, ठीक है? आपका V equal to root of VR square plus VC square, phi equal to tan inverse of opposite by adjacent, everything is same, but XC by R there, XL by R. So 1 by omega C R. Power factor here will be VR by V, that is R by Z only, but it is current is going ahead of voltage. We should speak with respect to current always. You can say voltage lag, current lead. To avoid confusion, always speak about current. So it is a leading power factor. So the next one is RLC, which is combination of RL and RC. VL equal to IJXL, VC equal to minus IJXC. Okay. So what is your KCL? KVL is VR plus VL plus VC. Voltage in the resistor always in phase. Voltage in the inductor always plus 90 degrees. Capacitor always minus 90 degrees. So now two vectors are in opposite direction by 180 degrees. The resultant will be subtraction of the both. So that is like this. So this is VC. Suppose VL is more magnitude, result will be VL minus VC. If VC is more magnitude, result will be VC minus VL. If both are equal magnitude, both will cancel. So three possibilities: VL greater than VC, VC greater than VL, VL equal to VC. When VL greater than VC, you get XL greater than XC. When VC greater than VL, you get XC greater than XL. When both are equal, you get XL equal to XC condition. So here what happens, the resultant will be sum of, first you subtract them and add VR. V will be root of VR square plus VL minus VC whole square. Here V equal to root of VR square plus VC minus VL. Here V equal to VR because VL minus VC 0. Angle phi equal to tan inverse of this by this or this by this. Power factor here, first case mein current will be lagging, second case mein current will be leading, third case it is in phase. We call it unity power factor. Okay. Here lagging means inductor is dominating, then it is lagging. Capacitor is dominating, then it is leading. Okay. Similarly, parallel RL circuit. Whatever we have done the analysis for series, let me analyze parallel also. Then we can start the problems. Okay. So the same analysis we can do for parallel also. So for parallel RLC circuit also the same analysis is applicable, but here series mein current is same. In parallel, what is same? Voltage is same. Current in the resistor is V by R, current in the inductor V by JXL or V by XL angle 1 by J is minus 90 degrees. By KCL I equal to IR plus IL. So what is your IR is this? IL will be angle 90 degrees denominator because down because of minus 90 degrees. Overall I equal to sum of these two. So phi equal to tan inverse of IL by IR. Okay, and V by R by, this is V by R, V by XL. So XL will come in the denominator, R in the numerator. Here also current lags only. KCL is not disturbed here. Don't think I equal to IR plus IL whole right, root of IR square plus IL square. Which one is correct? This is magnitude only. This is for both magnitude and base together. Power factor can also be given as G by Y also. Here R by Z is one way of power factor for the series. Similarly, parallel by G by Y is the power factor. Similarly, we can plot for RC also, RLC also. Okay. What is the condition for RLC is the same way. When you have previously XL greater than XC, here IC greater than IL greater than IC, what is the condition you get is 1 by XL greater than 1 by XC. Then this is IC, this is IL. Result will be IL minus IC. Overall is root of IR square plus IL minus IC. Phi equal to tan inverse of IL minus IC by IR. Okay, the same way if IC is more, you get it in the top. IR is ICIL equal, you get IR equal to what we call I, and power factor is 1. So let's start the analysis of the problems. Okay, so the first question is, I don't think this is, yeah, you can start with this question. Okay, give it a try. Last 3 seconds. Right, option A is the right answer. 22 ohms. It's a very simple question, right? He is not asking the phase, he is asking only magnitude. So the impedance will be, whatever may be the phase, Z will be equal to V by I. That is 110 by 5. Angle, okay, this is a 60 plus a 60, 120 degrees. Okay, so it is a 22 angle 2 pi by 3. Then both are in sine, both are in cos, no need to do any conversion. If one is in sine, one is in cos, we may need to do the conversion. Angle is not given, only impedance magnitude is required, means 22 is the right answer. Okay, chalo, let's move further. So a RLC circuit has a resistance of R equal to 20. The current which lags behind the applied voltage by 45 degrees. The voltage across the inductor is twice the voltage across the capacitor. Okay, what is the value of inductor reactance? Very good, give it a try. Time up, time up, time up. Yes. Option C is the right answer. An RLC circuit has a resistance R equal to 20, phi equal to 45 degrees. Okay. So R is equal to 20. Okay. The current lags means XL is greater than XC. Okay. Current lags the applied voltage by 45 degrees and the voltage across the inductor. What is the voltage across the inductor? IXL. I'm speaking about the magnitude. Is twice the voltage across the capacitor is equal to 2 times VC. That is IXC. So here XL is equal to 2 times XC is one information or XC equal to XL by 2. Okay, let's use them and solve the question. R equal to 20, phi equal to 45 degrees, XL equal to 2XC. What is your Z? R plus J XL minus XC. Okay, sir. And R value is 20 plus J into XL minus XC. What is XL minus XC here? XC equal to XL by 2. XL minus XL by 2, 20 plus J XL by 2 is your Z. What is phi, sir? Tan inverse of B by A. Tan inverse of B by A. Tan inverse of B by A is XL by 2 by 20. This is equal to 45 degrees. So इसका मतलब ये वाला part जो है ना ये 1 होना चाहिए. So XL by 2 equal to 20 sir. मेरा XL तो 40 होना चाहिए. सर बस हो गया question. दिस इज वन मेथड. अब इस क्वेश्चन को दूसरा मेथड से भी ट्राई कर सकते चाहिए तो. सो लेट्स सॉल्व बाय अनदर मेथड द सेम क्वेश्चन. Okay, so you can also do like this. Listen, this is the current VR, VL, VC. This is VL minus VC. This is phi. Okay, this is V. What is phi, sir? Phi is equal to tan inverse of, directly we can say VR by V. VL minus VC by VL minus VC by VR. So phi equal to tan inverse of VL minus VC can be written as I into XL minus X. This can be written as I into R. In this way also we can do. That is from the phasor diagrams I am doing it. XL minus XC by I into R. Or you can see the voltage, I mean what he said, the voltage across the inductor is twice the voltage across the capacitor. So VL minus VC equal to VL by 2 because this is VL by 2. Okay. So here tan inverse of VL by 2 is I XL by 2 by IR. This is 45 degrees. Again, same story na. XL by 2 by R must be equal to 1. R 2R equal to X. Any method. It is, you can do by phasor diagram, direct analysis, any method will give you the same answer finally. So let's move for the next question. A series circuit has an impedance of Z equal to, okay, good question. Don't think the question is as easy as you think. You take the option as option E. E. चलो चलो firstly don't think firstly yeah Z equal to R plus R minus X, Y equal to 1 by R plus R minus X. So it is R minus R plus X by R square plus X square. Okay. So this can be written as G minus R plus G. So what is your susceptance B of the overall network, not the element. Element का reactance चाहिए तो 1 by X. Element का conductance चाहिए तो 1 by R. This is for the overall network. For overall network, what is the susceptance is X upon R square plus X square. That is 12 upon 5 square plus 12 square. That is 12 by 160. 144, 169. Okay. Conductance चाहिए तो 5 by 169. Next question. So this is a good question. Don't think susceptance is 1 by 12. That is for the element, not for the network. That is, suppose you have a resistor and capacitor R minus Jx. You are finding the admittance of the entire network. इसका susceptance कितना है, entire network देखेंगे तो susceptance कितना होता है, ठीक है. So next question, give a try. You need to find IC of t. Last 10 seconds. Okay, let's do it. Omega equal to 1 radian per second. Inductance is J1. Capacity is 1 by J1 minus J. So you have 1 plus J parallel with 1 minus J. Whenever you have R plus Jx parallel with R minus Jx, R minus Jx, इस केस में क्या होता है सर, R1 R2 by R1 plus R2. So R square plus X square by 2R is the answer. Yes, A plus B into A minus B. Okay, that will give you A square minus B square. J square is minus 1. So 1 plus J into 1 minus J will give you what is the Z equivalent is R square plus X square by 2R, that will give you 1. So total impedance is 1. So this current I will be how much? I will be equal to 10 angle 15 degrees by 10 angle 15. मैं इतना क्यों कर रहा हूँ, ठीक है, सॉरी यार, करंट तो निकाला, वोल्टेज चाहिए तो you can do current division principle and find. You need IC of T, right? IC equal to total current into opposite impedance by total impedance, ठीक है. Ten angle 15 degrees into root 2 angle 45 degrees by 2. So 10 by root 2 angle 60 degrees. Okay. So ये RMS मान लो, then IC of T equal to 10 cos omega is how much? 1 T plus 60 degrees. Or if you take it as a maximum according to the examiner mode, plus 60. If 10, this is available, first priority. Okay. So 10 by root 2, this is equal to 5 root 2. Na? So 5 root 2 cos t plus 10 degrees is available in the options. Take that. Normally, if this is available, this is the first choice for your answer. Okay. Assuming this as RMS. Okay. If you take this as a maximum, this is the answer. Okay. So current division principle I have applied. सर इतना क्यों किया सर? आसान से कर सकते ना, कर सकते क्योंकि these are parallel पे voltage तो same है, So मैं डायरेक्टली ऐसा भी बोल सकते हैं IC इक्वल टू 10 एंगल 15 डिग्रीज बाय 1 माइनस जे. हो गया क्वेश्चन. यस और नो. मेरा IC क्या 10 एंगल 15 डिग्रीज बाय ओके रूट 2 real axis positive, imaginary axis positive, negative. So this question पे real positive, imaginary and negative is minus theta. Yes or no in the coordinate. So it will be tan inverse of minus b by e minus 45 degrees. That will give you 10 by root 2 angle 60. Single step में आपको आंसर मिलेगा. ठीक है. So directly ले जाते. नहीं तो ऐसा भी कर सकते हैं. You remember this whenever this kind of condition occurs, it always help you in the examination. R square plus x square by 2r. When you have r plus ax parallel with r minus ax. Okay. चलो. So in the circuit shown in the figure E1, E2 तो दिया, the voltage across the 1 ohm resistor is. ठीक है. So give it a try. Option A cos omega t. Okay. Here this can be written as okay, all are resistors only. Both are same frequency. So root 3 cos omega t minus 30 degrees. So you can take it in the time domain or phasor domain. It will be root 3 angle 30 degrees. Here root 3 angle minus 30 degrees. Because you are only writing it and you are finding again in the reverse. Whatever method you take, same ulta kar lo. I mean, when you try to represent the phasor in the phasor domain, I took maximum. Written also I write maximum. Always written is maximum only. So this is root 3 angle 30 degrees. This is root 3 angle minus 30 degrees. You get voltage across the 1 ohm resistor. So V minus root 3 angle 30 degrees V by 1 plus V plus root 3 angle minus 30 degrees by 1 equal to 0. So here 3V equal to root 3 angle 30 degrees plus root 3 angle minus 30 degrees. Cos 30 plus j sin 30 cos 30 minus j sin 30 दोनों cos 30 तो sin 30 तो जाएगा. Okay, so it will be 2 Just a moment. Okay. इसमें आप √3 कॉमन ले लो, वन एंगल, सो 3 एंड √3 तुम्हें कॉमन ले लिया, this will give me 3 angle 0 degrees equal to 1 angle 0 degrees, that is cos omega t. In vectors we can solve like this. Okay, two vectors with a phase difference of 60 degrees, the resultant will be equal to root of √3 whole square plus √3 whole square plus 2 times √3 cos 60 degrees is the resultant vector. Okay, so final answer will be cos omega t. 60 degrees may actually, if both the magnitudes are same, root of v square plus 2v into v cos 60 degrees may get √3 into v is the magnitude. Okay, when you have this is magnitude of v with 60 degrees phase shift, the resultant time speaking. Okay, so this will be √3 into v. The angle will be the median of both, that is plus 30 minus 30 का बीच में median angle will be 0 degrees. Okay, you can do by normal rectangular conversion and also do the addition, nothing wrong. So finally this will be √3 into √3 will be 3v equal to 3v, 3v equal to 3, v equal to 1 angle 0 degrees, that is cos omega t. If you take year RMS, you get the RMS, and again you need to convert into time domain में multiplying with maximum value. So few questions are left for your homework, guys. आप लोग तो try कर सकते हैं. So then now we will move to the next topic called a very important, exciting topic, resonance. Conventional, I mean comprehensive course में कम से कम मैं 6 घंटे लेता हूँ resonance के लिए, but आपके लिए we are doing it in the least possible time. So the next topic is resonance. So let's start. Just a moment. Okay, so resonance. Resonance in electric circuits is due to presence of your energy storing elements like inductor and capacitor. When the network contains inductor and capacitor, at one particular frequency, what happens? The inductor and capacitor will be exchanging the energy with each other. Because of this exchange of energy between inductor and capacitor, there will be oscillatory response in your network. We call it as a resonance. So let's see that. So resonance in electric circuits is due to the exchange of energy between inductor and capacitor. At resonant frequencies, there will be maximum response. Response will be maximum due to exchange of energy between inductor and capacitor. The resonance power factor must be 1. There are many applications for resonance like tuning circuits, filters, and many others. So I'm directly giving you the theory of the resonance, then we can directly move for the problems, right? um, so series and parallel RLC, if you take, already we know these things. Now listen here. What is the inductor reactance XL, omega L, capacitor reactance 1 by omega C. So XL is a constant straight line with respect to omega. Xc is 1 by omega C, na, it is inversely proportional. At resonance, both will be equal. Before resonance, Xc dominates. After resonance, sorry, XL dominates. So after resonance, lagging power factor. Before resonance, leading power factor. So same happens with the parallel, but here y equal to 1 by R plus 1 by JXL plus 1 by JXC minus 1 by JXC. That 1 by Xc is omega C minus 1 by omega L. Here before resonance, and this is your 1 by omega L, that is 1 by XL. After resonance, 1 by Xc, omega C will dominate. That is lead and lag will be reversed. So see here, the series RLC circuit mein, at omega equal to omega naught, imaginary term must be equal to 0 to get the unity power factor. So XL equal to Xc, omega naught L equal to 1 by omega naught C. That will give you omega naught equal to 1 by root LC. The same happens with the parallel also. I'm going little quickly because we need to do the problems. Theory just like a revision I'm giving you. So series RLC circuit में omega excuse me, omega equal to omega naught, Z R will be minimum. Okay, R will be minimum, so it accepts maximum current. I will be maximum, so it is also called acceptor current. In parallel RLC, at omega equal to omega naught, Z will be maximum. Okay, because Z equal to R, that is the maximum possibility. R parallel with anything is R is the maximum possibility. Y will be minimum because impedance is maximum. It is called a resistor circuit. So if you take the series RLC circuit at resonance, omega equal to omega naught, Z equal to R, V equal to I Z, where Z equal to R. So I will be equal to V by R. So what is the voltage across the resistor is I into I in the current in the resistor into R. Current in the resistor is V by R into R. So the entire voltage you have applied will be across the resistor. What about the inductor is IJXL? I is V by R into XL is omega naught L. Now we replace omega naught L by R with quality factor Q. So voltage across inductor will be multiplied by Q times. Similarly, capacitor में IJXC, where XC equal to 1 by omega naught C, I equal to V by R. This 1 by omega naught RC is called quality factor Q. So QE angle minus 90 degrees. So here in the resonance circuit, voltage across resistor, inductor, capacitor, VR equal to V, VL equal to QV, VC equal to also QV. The voltage will be magnified by Q times. This is called voltage magnification circuit. Similar to series, parallel में क्या होता है sir? At resonance, voltage across the resistor equal to voltage across the network equal to V is I Z, Z is R, V equal to IR. So current in the resistor is V by R, where V equal to IR if you substitute. The total current will be across in the resistor only. What about inductor capacitors? Sir? They will be exchanging the energy with each other. Same way, V by XL V equal to IR. R by here, quality factor will be reversed. We can prove it also. There omega naught L by R, here R by omega naught L. Similarly, there omega naught 1 by omega naught RC, here omega naught into RC. Current in the capacitor will be QI. Or here current is multiplied by Q times current magnification circuit. So if you take the frequency response of the network in the series RLC circuit, Z equal to R plus AXL minus AXC, R plus J into XL minus XC, R root of R square plus omega L minus 1 by omega C whole square. So current I equal to V by this one. When omega 0, this part will become 0. 1 by 0 is infinity. So what we call your Z, sorry, 1 by 0 is infinity. So Z will be infinity, 1 by infinity, current will become 0. The same way, omega equal to infinity, this part is infinite and current will be 0. Omega equal to omega naught, this part will cancel, you get the maximum response. So the response will be like this. At resonance, you get the peak response, after that it will decrease. So you can see current, this will reach its peak at what we call resonance. Before we take 2 points, intermediate points, where the current falls to 1 by root 2 or power falls to 50% of its maximum value, which defines your bandwidth. So omega L and omega H. Here, Current reaches its maximum value means don't assume that IRMS and IMAX the maximum. This is the maximum possible RMS value. It is the RMS values under different frequencies. At this frequency, you get the maximum value for the RMS value of your input. Because people will confuse IM and IM by root 2 as maximum and RMS value 100% wrong. Here it is not for same frequency. With respect to omega, different omegas your magnitude of the current is varying like this. At this omega, your magnitude will be highest possible. Here highest possible by root 2. Okay, so all of them are resistant, this representing the same. If it is RMS, this is also RMS. If it is maximum, this is also maximum only. So different omegas we are plotting the value of the RMS value. At this omega, the RMS will be highest possible. Here RMS will be highest possible by root 2. That is the meaning of that IM here. So here the power is IRMS whole square by R, that is IM square by R. Here power will be 1 by root. So there are some relations which are very important. Quality factor Q equal to omega naught by bandwidth. So bandwidth increases, Q decreases, and so on. So if Q increases, bandwidth will decrease, and you can select your frequencies more finitely. इसलिए इसको बोलते हैं selectivity factor. So quality factor को. So Q naught equal to root of omega h into omega L. Here, what is the bandwidth? Omega naught by Q, where Q equal to omega naught by L by R. So the bandwidth formula is R by L. So you can derive omega h and omega L by taking I equal to Imax by root 2. Imax by root 2 में Imax is V by R by root 2. I is V by Z. If you equate Z with R root 2 magnitude में, you get the omega h and omega L formulas. To remember easily, this is the formula. याद करना चाहिए. Plus or minus bandwidth by 2 plus root of bandwidth square by 2 plus omega naught square. That bandwidth is this formula. Okay. The same analysis is applicable for parallel also. Okay, but here current voltage will reach its maximum value. Okay, and all other relations remains the same. Bandwidth will be omega naught by Q. Q is 1 by omega naught RC, so 1 by RC is the bandwidth. And omega h, omega L same way, bandwidth by 2 plus root of bandwidth by 2 whole square plus omega naught square. So the quality factor Q is given by 2 pi into the maximum energy stored per cycle by okay, this is the formula for the quality factor 2 pi into maximum energy stored by energy dissipated. Energy dissipated per cycle is given by average power into time, or average power is energy dissipated per cycle by the time period, average power. So by using that maximum energy by average power. So you can derive this quality factor if you want. I am not going through the derivation because of the available time. Already I have given the final conclusion. So series RLC, what is Q? Just a minute. For series RLC, Q equal to omega naught L by R. But you know, omega naught square equal to 1 by LC. So L can be written as 1 by omega naught square C. 1 by omega naught RC. Omega naught is 1 by root LC. That will give you 1 by R root of L by C. So when R increases, Q decreases. I'm sorry, excuse me. Similarly, parallel RLC. Okay, this is inversely proportional to bandwidth. So R decreases, Q increases, bandwidth decreases, R0, bandwidth will become 0. Okay. Here R increases, Q increases. So this will give you the variation of VR, VL, VC with respect to omega in a series RLC circuit. At omega naught, the resonance both will be equal. Before resonance, VC will reach its maximum. After resonance, VL will reach its maximum. So this is the frequency where the what we call VC will be having its highest possible, that frequency is given by 1 by root of 1 by LC root of R square minus 2L square. The frequency where omega L will be maximum is given by 1 by root LC minus C square R square by L. Better, I mean, अभी तक तो directly नहीं आया, अगर आएंगे तो better to remember. The frequencies where VL and VC will reach maximum. This will be before resonance, this will be after resonance. Similarly, we can plot for IR, IL, IC for the parallel, but first there IL will come, next IC will come. So this is a very important network, most frequently occurred network in the problems. RL, RL, L, RC, C. Its resonant frequency is root of 1 by root LC root of RL square minus L by C by RC square minus L by C. इसमें specific condition, अगर RL 0 है तो क्या होता है, RC 0 है तो क्या होता है, just इसमें substitute कर लो. Remember this compulsory. And here, if RL, RC both are same and R square equal to L by C condition is satisfied, then the network will be at resonance for all frequency, that is infinite number of frequency. Network will be at resonance for any omega. Impedance will be resistive or unity power factor can happen when R square equal to L by C, omega equal to omega naught for any omega. This is a special case important with respect to examination for this network. That's all the theory. Okay, now let's solve the questions. So the first question is ready for you. Just simple theoretical questions, right? So let's start. Okay. So circulating current in the parallel resonant circuit at any resonant frequency is directly proportional to frequency, inversely proportional to frequency, independent of frequency. Actually here, if you have L, 1 by SC. Okay, suppose this circuit is there. I find the Laplace transform and find the response. So your V naught into root of C by L cos omega nt is the response you will be getting. Okay, that is your I in the steady state. Okay, the exchange of energy between inductor and capacitor we are speaking. It is a function of the frequency. Okay, so in a series RLC circuit excited with E equal to sin omega t, when LC less than, okay, what happens? This is a simple question you can answer easily. In a series RLC circuit excited by a voltage E sin omega t, LC omega is here. omega is less than 1 by LC. Okay. So omega less than omega naught, it is series RLC na lead. After omega naught lag na pehle lead. So current is in phase, no, current leads the voltage. Next question. Here also a theoretical question, ज़्यादा time तो नहीं चाहिए. हो गया time. So in a parallel RLC circuit is at resonance, sum of inductor capacitor currents will be maximum. JQI minus JQI na at resonance, both will be 0. In parallel resonance circuit is the current accepted at resonance is maximum. No, minimum na? Yes or no? It is a resective circuit. Series RLC circuit, the angle between inductor and capacitor voltages. Yeah, this is VL, VC, 180 degrees. ये तो 90 or 80, 90. So only first option is correct. Next one. So RMS के बारे में अभी discussion नहीं हुआ ना, छोड़ दो. Okay, try this question. It's a good question. Okay. So at resonance, what is the condition required? Don't say XL equal to XC. Imaginary part of the impedance or admittance must be equal to 0. So if you find what is the Z1 here? 5 parallel with minus JXC. 5 minus 5 into XC by 5 minus JXC. Right? डिनोमिनेटर और न्यूमरेटर में इसको कॉन्जुगेट से मल्टीप्लाई करो, माइनस जे 5xc 25 minus j 25xc, j square is minus 1 plus 5xc square by 5 square plus x square. Okay, इसमें ओवरऑल z इक्वल टू minus j10 plus minus j25 xc by 5 square plus x square plus 5x square by 5 square plus x square plus 5. ये पार्ट को जीरो करना चाहिए, ठीक है. j term must be equal to 0 for resonance. So माइनस J10, सॉरी प्लस J10 है ना, ये इंडक्टर, ये तो कैपेसिटर है ना, दोनों के, अरे यार J5 होना चाहिए, ये इंडक्टर है, सॉरी टाइम वेस्ट हो। So if you take this J1, you take it as a Z1, and this is minus 10. So Z1 equal to plus J10. Then omega equal to omega naught, because it will be at resonance, because the imaginary part will be cancelled out. So J5 into minus JHC by J5 must be equal to my J10, right? So here J square equal 5xc by J into 5 minus xc must be equal to J10. So 5xc by 5 minus xc must be equal to J square is minus 1 or minus 10. So 5xc by 5 minus xc must be equal to minus 10. So 5xc equal to minus 50, minus into minus plus 10xc. So minus 5xc equal to minus 50. आपका xc कितना होना चाहिए सर? 10. So when xc is equal to 10, this equivalent will be plus J10, and overall will be equal to resistive. So overall impedance must be resistive for the resonance. Next question. There are some questions which are not part of resonance or calculations. Tomorrow we discuss that. Okay, give a try for this question. Steady state analysis already discussed here. Right. You can solve this question by different methods. One is by using Laplace transform transfer function approach. Also, you can solve it. Decide Laplace transform by excitation Laplace transform method. Otherwise, see here. This is a J1, because here omega equal to 1. So circuit में steady state current through the inductor चाहिए ना. Okay, this is J1. This is 1 by J2. Okay. So here, what is the Y of the inductance is minus J1. What is the admittance? YC 1 by minus JXC, 1 by minus J2. So 1 by J omega C. yc equal to z. Fine. Okay. Now this is one. Okay, you need this current. You know this is 2 angle 0 degrees. Sine is the my reference. Okay. Then what is the current in the inductor? Direct formula is total current into total current is how much? 2 that particular admittance by total admittance 1 minus j1 plus j2. So minus j2 by 1 plus j. So 2 angle minus 90 degrees by root 2 angle 45 degrees. So here 2 by root 2 is root 2 angle minus 135 degrees. Okay. So what is your IL of t? I took sine as my reference. I took maximum value only in the representation. I treat this as the sine and maximum value. Sine omega t. Omega is how much? T minus 135 degrees. That is 3 pi by 4. Okay. Current division principle directly applied when admittance is directly available. Total current into that particular admittance by overall admittance will give you the answer. Okay. So IL of t equal to root 2 sine 3 minus 3 pi by 4. Say actually, okay, these things we can discuss a little later. Find this. Okay. So here, so steady state may this will become anyway 0, right? So that you can neglect it. Inductor is J, omega is how much? 1000, so J1. Capacitor 1 by J1 because 1000 and 1000 micro. Okay. So J1 parallel with minus J1. I already discussed what is that? 1 square plus 1 square by 2 into 1. That is your Z equivalent. 1. So total Z, this is Z1. Overall Z equal to 1 plus 1. The network will be purely resistive here, 2. So the current I will be 5 by root 2. 5 root 2 by root 2 कितना होता है sir? 5 root 2 by 2. 5 by root 2. Cos 1000 t. That's is it correct? J1 and 1 by J1 is minus J1. Mhm. Okay, that is R plus Jx by R minus Jx. No? So why I applied here? Wait. So what is the equivalent? Z1, Z2 by Z1 plus Z2 will give you infinity. Our overall admittance is equal to 1 by J1 plus J1. So minus J1 plus J1 to 0. Okay, impedance is infinity. So this will act like a open circuit. When it is open circuited, okay, you can also do 1 by root LC for the parallel circuit is. Here you can do like this also. 1 by root LC. क्या होता है सर? 1 by root LC 10 power minus 6 का root 10 power minus 3 in the denominator 1000. So open circuit parallel में see parallel LC में resonant circuit will be open circuit. If it is series LC circuit, omega naught में short circuit. ठीक है? So in any way you can say it is an open circuit, so no current will flow in the steady state. Option A. Right. So that is about your today's class. बाकी जो है ना power supplied, power dissipated, ये सभी चीज जो होता है ना, वो तो हम tomorrow class में discuss कर सकते हैं. ठीक है? That will be the last class. Tomorrow I will discuss average RMS values, power calculations का content, then coupled circuits and three phase also. Possibility है तो लेता हूँ, नहीं है तो one more class I will take, no problem. Okay. And as I promised you, I am finishing the syllabus on time. Okay. So I hope you know the new batches were started for plus subscriber students, guys. So if you want to take the subscription, don't delay it. इसमें आपको बहुत सारे advantages भी है, comprehensive coverage of the syllabus, and daily practice paper मिलेगा, special exclusive live classes, practice and strategy sessions by top educators, आपको test series भी मिलेगा, ठीक है? So these are the batches running on right now with Unacademy. So आप IRMS भी prepare करना चाहे तो you have the Unacademy UPSC and GATE combo subscription. You can use the code Shankar10 and subscribe to the IRMS and UPSC and GATE combo. मिशन IRMS में आप सब्सक्रिप्शन ले सकते हैं एंड आपको इस बार जो क्लासेस है ना प्लस में we will also cover the mains part, conventional part also, so that it will help you for ESC and IRMS also. Okay, so if you want to crack both of them also, you can use my code. So all India level examination is going to happen. That is next January. May 4 exams are going to happen. Don't miss this chance, guys, because this is the way where you need to test yourself. All India level examinations. Identify your mistakes. अगर कोई गलत कर रहा है तो करेक्ट करने के लिए भी आपको डिटेल्ड एनालिसिस मिलेगा इस एग्जाम के बाद. वीडियो सॉल्यूशंस में मिलेगा टू क्रॉस चेक एंड कॉम्पिटिटिव एनवायरनमेंट में हाउ यू आर परफॉर्मिंग इन द रियल टाइम यू कैन नो. So before real time exam, you can have you got a chance to overcome your mistakes. So link is available in the video description. So AMT का enroll करने के लिए आप मेरा कोड भी यूज कर सकते हैं. Thank you. So that is the starting part of the AC analysis. Tomorrow we will discuss little more also. And again I am saying Unacademy में अभी तो offer चल रहा है 23% offer on Unacademy subscription. Okay. So don't miss this chance. You will be getting a 23% subscription and 23% discount on an Academy subscription. Don't miss it, guys. Thank you.